Lithium batteries have a lot of advantages over the old school AGM type. They're a lot smaller, they're a lot lighter, they can charge and discharge much faster, and they have a much higher cycle count. These are all the advantages, but what are the downsides? If you dead short them, are they going to catch on fire? If you get them wet, will they still work? What if you completely discharge them? What if you actually freeze one of these batteries? Well, I'm the kind of guy that wants to find out. So today, we've got Renogy's latest 100 Pro lithium battery. This thing's rated at 100 amp hours. I want to put it to the test. Let's be brutal to it. Let's try all of those things and a lot more. Find out just how tough this battery really is. I'm Dan, this is The Road Chose Me. On with the testing. I've always wanted to know what happens when a lithium battery gets cold. And I mean really cold. So I stuck it in the freezer, came back the next day and pulled it out. Now let's do some testing and see how it performs. So I've just taken the battery out of the freezer and I've packed it on ice to make sure that it stays cold while we're doing all of this. And it's really fascinating. If I have a look on the app right now, the battery, I discharged it yesterday down to about 75%. And you can see there are quite a few warnings going on right now on this battery. So it is kicked in and it is protecting itself because it's cold. You can see I got it down to minus 14 Celsius, which is about 7 degrees Fahrenheit. And a couple of the warnings here, we've got a charge low temperature protection, we've got a discharge low temperature warning, and we've got a charge low temperature warning. So basically the battery's warning us it's really cold right now, and I'm interested to see what happens if we try and charge this thing right now. So the way that these work is when they kick into protection mode, you need a battery charger that has like a lithium revival mode. And I just so happen to have one of Renogy's DC-DC solar chargers here. And so I'm gonna hook this up. I've got a mighty big solar panel over there. Let me just wire this all up and then we'll check out what actually happens when you try to charge this thing when it is this cold. We'll leave it packed on ice and it should still be nice and cold by the time we start charging it. So I've got the charge controller hooked up to the battery now. I just have to connect the positive terminal of the solar. And let's watch what happens as I do that. No comments, please, on my sketchy wiring over here. So the solar of the charge controller is now connected, which means if we go back to Renogy's home app, we can see the charge controller has shown up there on the right-hand side. And if we go in, we can see, so it currently says that it's charging the house battery at 58 watts. The solar panel is putting out 35 volts at 2 amps. It's a big solar panel and it's got lots of sun on it. But if we go back and have a look at the battery, it currently says that it's charging at 0 amps, which is really interesting. But then when we come down and have a look, it says heating module status on. So it's actually using the internal heater right now to heat the battery up, which is really fascinating. The way that the heating module works in these batteries, it won't consume its own power to heat itself, so it'll never do that. But if you supply it with external power through a charge controller, it could be DC to DC off your alternator, it could be off a solar panel like I'm doing right now, that will then turn the heating module on and that'll start warming the battery. Then once the battery reaches whatever predetermined temperature it is, it's safe to charge it, it's safe to use it, and all of those protections will come off. And we should see those protections will come off and then it'll actually start charging off my big solar panel over there. So I'm gonna let this sit for as long as it takes. I assume I might need to take that ice out of there. Otherwise, at some point, I'm just gonna wind up charging this thing while it's sitting in a puddle of water. So we'll see how long this takes for the heating module to bring it up to temperature. But this is really interesting to see. The heating module is on. It's actually heating itself off a solar panel right now. Interesting stuff. So I've been watching the temperature like a hawk. It's been almost 40 minutes now, and it's just about to hit 3 degrees Celsius. And when it does, that is the point that it'll take off those protections and it'll start charging again. So I was reading the manual at 0 degrees Celsius at 32 Fahrenheit. That's when it says, this is too cold. I'm not going to accept charge anymore. So you can't charge the battery when it's colder than that. Then the heating element turns on once you connect some sort of charger to it. It'll warm itself back up. Then when it hits 3 degrees Celsius, which is 37.5 Fahrenheit, that's the point where those protections will come off and it'll allow us to start charging it again. So any second now, those protections are going to come off and we'll start to see current flowing into the battery. And there we go, it just kicked over. So the minimum temperature of the battery went over 3 degrees Celsius, and currently we are charging the battery with 19.5 amps of current. And you can see the heating module is still on, which I didn't know if it would stay on or not. And so we can see here back on the main screen, we're putting in nearly 20 amps of current, and it's going to be fully charged in 1 hour and 20 minutes from 74% obviously up to 100%. So there we go, that's pretty interesting. The battery looks after itself. If you freeze it, it's not going to let you damage it by either discharging it while it's too cold or charging it while it's too cold. And looking at the manual, it does exactly the same thing if it gets too hot. It has these trigger points where it'll disconnect itself, and then it has points where it will eventually take those protections off again once the battery reaches the temperature range that is safe to operate it in. I always wondered what would happen if you froze a lithium battery. Now I know. The next thing I'd like to test on this battery is what happens when you directly short the negative terminal to the positive terminal. Now there is an enormous amount of energy stored in here, and definitely back in the day with these batteries, if your battery vibrated loose, if somehow the two terminals wound up touching something metal, they would basically arc weld themselves together. You would have an enormous amount of sparks, probably even fire, firstly from the sparks, but also from internal to the battery. Really, really bad time, and I know people were really worried about it, and more than a few vehicle fires have been attributed to battery terminals shorting out. This is a smart lithium battery. This thing is supposed to have some protections built in. Well, there's no way to know if they work unless we actually test them, right? So I've got the DC Smart Home app open again. I'll just start screen recording to show you guys what's happening. You can see the battery's still at 75%, obviously not connected to a charger or anything like that. And here I've got some welding cable. This is 1/0, so this is enormous current carrying cable. I don't even want to know how much current you'd be able to put through this thing. And I'm expecting some sparks here. I'm expecting something interesting to happen. So safety first. I've got my gloves on. I've got some safety glasses on. Let's see what happens. We're connected to the negative terminal. Let's direct short to the positive terminal. Here we go. And there you go. You saw there was a pretty big spark, but only for a fraction of a second. And the battery now, you can see on the screen, discharge over current warning. And so what that's done is it's effectively turned the battery off, and it said something bad was going on, so I disconnected myself until you rectify the situation. And actually just watching the app, that little warning just went away. Reading the manual, what it does is it lets you have a 10-second window to correct the problem. And it says, oh, the problem has been corrected. Okay, I'm gonna turn myself on again. So I should be able to induce that same scenario. There it goes, a good spark. And on the screen, there we go, discharge over current warning. It's done it again. And if we wait for it, I think I get a second chance at this, where the battery will again, in about 10 seconds, it'll check to see if all of the wiring has been rectified, and it will turn itself back on again. And there it goes, that warning has gone away. So that's pretty interesting. The battery will actually protect you from just arc welding itself really, really badly. But what happens if the problem isn't rectified? What happens if this thing really did just connect two pieces of steel together, like for a really long time? Well, again, there's only one way to find out. Safety glasses on. No spark that time, interestingly. But what I'm gonna do is I'm gonna keep it there with my hand and see what happens here. So the app is now saying discharge over current warning. And because I'm holding it there, I think what's going to happen is in 10 seconds, the battery is gonna try again. It's gonna realize the problem still persists, and it's now going to make this permanent. The battery is going to permanently disable itself and say, something has gone very, very wrong with the wiring setup here. This is not good. I don't want to dissipate my 100 amp hours of energy into the frame of the vehicle or whatever else is going on. So the battery now has actually turned itself off. And that's it. It doesn't matter what I do. The thing is, for all intents and purposes, no use anymore. Pretty interesting. It's like saved you from your own bad decisions or bad situation, whatever happened. So what you would do then is you come into the app and it says, oh, something's gone wrong. The battery has turned itself off. It even particularly says that. So what are we going to do about it? How do you now resurrect this thing or correct the problem? Well, Renogy have thought about this. What you need to do now is connect this thing to a battery charger that has what they call a lithium revival mode. All of Renogy's chargers have it. Obviously, all the big ones on the market do. Because what that'll do is when current starts flowing back into the battery, the intelligent battery sensing inside of it says, the wiring appears to be safe. Nothing here is a direct short anymore. So it'll revive itself and it'll turn itself back on and be good to go again. Another thing I've always wondered about lithium batteries is what happens if they get wet? How delicate are these things if you accidentally spill some water on them? I mean, who's going to find out other than me right now with this garden hose? So let's spray some water on it. I'm going to get myself out of the splash zone. I was just charging it too. It's up at about 80% capacity right now. And I can actually open the DC Home app right now and we can see the battery's perfectly fine. It does not care at all that we are spraying it with water. It makes no difference whatsoever. So actually that was a bit anticlimactic, wasn't it? Why don't we try something better? You need to make sure it's nice and covered. It's not over the top yet. So there we go. The battery is completely immersed in water, both terminals, and it's currently at about 80% of its full capacity. So why don't we leave it here for 10 or 15 minutes and come back and see how it's doing? Funny enough, I'll be able to monitor on the app the whole time it's in there because you can just check with Bluetooth how it's doing. So yeah, let's see what happens. So I've just taken the battery out of the water after 10 minutes. Doesn't seem like anything happened at all. Let's get it charging for the next test and we'll just make sure that everything's fine with it. I don't see any reason it won't be. So there we go, battery's still wet. Connected to the charger to a big solar panel and we're charging it 17 amps. We're at 76.4%. It's going to be an hour and a quarter until it's full. Battery's totally fine. Couldn't care less about being underwater. And that's because this thing is IP67 rated. So yes, it has a waterproof enclosure. It totally doesn't even care about being underwater. So, I mean, not that I ever plan on having mine underwater, but pretty nice to know that it's not going to hurt it, it's not going to catch on fire, you know, it's not going to burn your vehicle to the ground just because you went into a deep water crossing and got your battery underwater. So pretty nice to know. I'll just give you guys a quick tour of my full setup here while the battery's charging up to capacity. So you can see there's the battery, there's the Renogy charge controller, DC to DC and solar. You're going to be seeing a bit more of this in an upcoming episode. And I've got it hooked up to this monster solar panel right now. That's actually what's charging the battery. And I'll just turn on screen recording on my phone. So then now it'll pop up on your screen. You can see in the Renogy app, we can see we're putting in 22 amps into the battery. It's at 80.4% and it's going to be fully charged in about 53 minutes. So this all obviously works over Bluetooth to the battery and to the charge controller. You can see them both on the screen. What happens if we get further away though? Right now I'm only about 2 feet away from the battery. So let's back up a little bit. Now I'm 2 meters away, about 6 feet. And I can still refresh just fine. And I can still talk to the battery and see exactly what's happening with it. If I back up a bit more, so I'm 3 meters, about 10 feet. refresh the app, and it refreshes no problem at all. And of course I'm doing this on a janky old iPhone 6 that's a little bit worse for wear, so I imagine if you had a newer phone the Bluetooth might work even better. Let's back up a bit further. Now I'm clearly 4 or 5 meters away. I'm well over 10 feet away from the battery, and still I can just get the status of everything no problem at all. So this is obviously much further away than you need to be, but you know, anywhere you are in camp, if this thing is in your vehicle or in your boat or something, you can actually see what's happening with the battery from quite a long distance away. But that is impressive range on the Bluetooth. So in terms of monitoring the battery and seeing what it's up to, you could go a long distance away from it. So after all of that abuse, let's start testing what happens when we pull energy out of this battery. And I've got quite a complicated setup here in front of me, so I'll give you a walkthrough and show you what's going on here. So closest to you guys, I've got the 100 Pro battery, and in essence, I've got it connected directly to Renogy's 3000 watt inverter. This is their biggest inverter. This thing can use an enormous amount of energy. Coming out of the inverter, I've got it plugged into this power board, and then I have quite a few high current things plugged into the power board. So I've got a kettle, I've got a hairdryer, and underneath I've got our toaster oven. All of this is to try and draw as much power out of the battery as I possibly can. And I want to monitor what happens while power is coming out. So the first thing I've got is a GoPro here recording the Renogy app so we can watch current flow. And I've also got an old school battery meter. So there's the meter down there, and you can see in the GoPro view what it looks like. And to measure the amount of current flowing, it uses what's called a shunt, which is kind of this resistor. And basically by watching the voltage drop, it can measure how much current flows through it. So from there, we'll be able to measure how many amp hours we draw out of the battery, how long it takes, all of that kind of stuff. That'll be fun to have up on the screen while we're drawing current out of the battery. So that's the setup. Now it's time to get testing. So this battery is rated to deliver 100 amps continuously, which is kind of the maximum it can do before something bad's gonna happen. So I wanna find out what happens if we do more than that. Well, officially it's rated to deliver 245 amps for up to 30 seconds. And then I imagine something is gonna happen. Let's find out what happens. So I'm gonna turn on all of the high current devices I can. We'll pull out as much energy as possible, and we'll see just how long the battery lasts. So I'll flip on the kettle, I'll flip on the toaster oven, and I'll plug in a really big work light. All of these now are pulling out of the inverter, and we can straight away see the Renogy app says we're pulling out 175 amps. That may actually go up here in a second. It says 191 amps, and interestingly, the old school meter says 190 amps. So this is really interesting to compare how accurate are the two gauges. Old school 190, 189, Renogy's app 189.5. So I think it's safe to say they're pretty similar. And obviously this is an enormous amount of energy. At this, the battery will be depleted in about half an hour, but this is more energy than you would ever use from your fridge, from anything like that. So I'm curious to see, the battery's doing it still. The kettle's boiling, the light's on, the toaster oven. Oh, and there it goes, it's all shut down, and we have a discharge over current protection. So there it is, that's what happens when the battery delivers so much current in such a short amount of time. We lasted, well, I'll have a look on the footage. And so from here, now that I've got that over current protection, I think if we give it 30 seconds, it'll turn itself back on again, or I'll just have to connect it up to a charger, do the lithium revival thing, and then we'll be good to go on our next test. So now it's time, finally, to test the capacity of this battery. So you can see on the app there, Renogy says it's actually 101.97 amp hours, which is a little bit higher than advertised. Let's find out though, what happens if we try to actually take that much energy out of the battery. So I've got it charged back up to 100%. I've reset all the numbers on the old school analog meter. I've got that up on the screen for you. My game here is going to be to try and draw exactly or as close to 100 amps as I can for this entire test. So my combination of appliances, I'll get them stabilized, and then we should be able to draw around 90 to 100 amps for the entire time, which should take about an hour. We'll see that on the elapsed timer. So things are about to get noisy around here. Let's go for it. The full energy drain test on the 100 Pro battery. What happens when it gets to 0? Let's find out. So before I speed up the footage of the 2 meters, there's a couple of things that I want to point out you should keep your eyes on. The first one is the bottom right there. That is elapsed time, so that'll tell you how long the test has been running. The other one, as I pointed out earlier, is the number of amps that I'm currently drawing out of the battery. And you can see I'm trying to keep it as close to 100 as I can, but I don't want to go over 100 because that would trigger the protection mode of the battery and invalidate the whole test. The other really interesting one is the top right-hand corner of the old school meter shows how many amp hours we've pulled out of the battery. And it takes a second before it ticks over into whole numbers of amp hours, but then it's fun to watch because this is a 100 amp hour battery. For every amp hour we pull out, we would expect Renogy's display to show 1% less of capacity. That would track and that would make sense. And you can see the old school meter is updating instantaneously versus Renogy's app. If you don't force a refresh, it updates about every 20 or 30 seconds. But if you choose to, you can manually refresh it much faster than that. And the other thing that's worth keeping an eye on too is you can see the voltage of the individual cells inside the battery. Renogy actually show us that in their app. So we can see if the cells remain balanced as it discharges or if they get imbalanced, which would be a bad thing. And then finally, we can see the overall voltage of the battery. If you did get a multimeter and stick it on, that's how many volts the battery would read. Always a bit interesting with a lithium. You can't necessarily tell how charged it is just from how many volts it reads. But anyway, that's enough yammering from me. On with the test. Let's speed this up. Coming back down to regular speed now, you can see the test has been going for just over an hour. I've taken out 96.5 amp hours, and Renogy's meters say that the battery is at about 11%. And so things start to get interesting here. When the battery hits 10%, Renogy starts throwing up some warnings that it's getting low, and then things get really interesting after that, and I come back to keep an eye on it. So there we go. Everything has just come to a grinding halt. The Renogy app says we're at 6.1%, and the old school meter said that we'd pulled out 100 amp hours and exactly 1.28 kilowatts, which is exactly what you would expect from a battery of this rating. Also to note, the Renogy app says we're down to 11.1 volts, whereas the old school battery meter actually had it lower than that. We were pulling out almost 100 amps then, still 98 amps. So I wonder if that had something to do with it switching off like that. It couldn't sustain such a high current draw. Let me turn the inverter off and we'll see if the battery comes back to life. But yeah, there's the test. You can see it took me a little over an hour to do that because I wasn't quite able to maintain exactly 98 amps of current draw. My appliances kept switching off. My toaster oven would reach temperature and turn off. I unplugged and replugged a few things here and there. But there you go. The old school battery meter says we pulled out 100 amp hours, and that's interesting. The Renogy app, well, it's probably, it's got an under voltage warning, but it's probably disconnected itself. So right now it's saying we're at 0%. But I would say that is a very successful test. We pulled out almost 100 amps the entire time. So as rated, this battery delivered 100 amp hours, which is what it's supposed to do, which is right on 1,280 watt hours as rated. So there you go. That's what happens when you draw one of these down low enough. I'll hook it up to a charger now with the lithium activation, and I'm sure it'll turn itself back on and it'll start charging. I did notice too, the warnings came on right when it hit 10%. So obviously at a 10% level, that's its trigger. And then the inverter started viciously beeping at some point there as well. I think it was realizing the voltage was too low and the inverter gets to a point where it just turns itself off. So there it is, the full capacity of the 100 amp hour battery. As rated, I think that's good. There's a couple more things about this battery that are quite impressive. One of them is that this is a flame-proof case. So I could actually try to set it on fire from the outside and I would probably fail, which is not really something I'm too excited about. But the other thing is it's designed not to allow fire to spread, so that even if one of the cells did somehow manage to catch on fire, it wouldn't propagate into the other cells and the entire thing isn't going to burn down. As much as that could be fun to test, I actually want to use this thing in my Jeep, so I'm not too excited about destroying it. Maybe someone else will actually put a blowtorch on it and see how it goes. And the other major thing about this battery is it was designed with vibration in mind. So, you know, the kind of places that I like to drive around the world, whether it's Africa or the remote parts of Australia or South America, I basically beat up my equipment on tens of thousands of miles of corrugations. So anything I bring with me has to be able to withstand those vibrations, and this has been designed with that in mind. With all of that said, I'm impressed how this battery has performed. Basically, I was about as mean to it as you can be, direct shorting it, freezing it, putting it underwater, and it still works perfectly. That capacity test was the last one that I filmed, so that was after I had already done all of those nasty things to it, and it still works flawlessly. That's really good. I'm super happy with that. So I'll be installing this in my Jeep in the next episode. If you're interested in picking one up, there's a link in the description and a 5% discount code that Renogy have supplied. So you can buy one of these right now on Renogy's site. And as I mentioned, this is the 100 amp hour version. Renogy are just now releasing a 200 amp hour version of essentially the same thing. So obviously it's bigger and it has twice the capacity, but otherwise all the design features are identical, so it will handle all of my battle testing exactly the same. You're basically just getting twice the amount of storage. So that is a battery I really have my eyes on to go in my new Jeep camper. So as always, if you have any questions about any of my testing or anything else going on here, feel free to drop a comment down below. I'm happy to answer questions. I'm happy to take more photos or explain any more aspects of the battery or the testing that I completed on it. And if you'd like to learn more, as I said, there's a link in the description. Head over to Renogy's site and you can learn a lot more about not just the 100 Pro battery, but also the charge controller I was using and a bunch of the other equipment that I'll be installing into my Jeep camper. So until next time, have fun out there and maybe I'll bump into you on the road.